Welcome back to the demo section. This week we will shift our gear from the vector analysis to raster analysis. Since raster analysis apply a totally different approach, there is one big reminding before we start. The most raster layers are still having problem to live in with the geodatabase. Hence, for most raster analysis, what will be suggested here is creating a specific folder for raster analysis result. The outline here includes raster analysis 1 and 2. In raster analysis 1, it is important to understand structure and operation rules for raster dataset. So there are three fundamental portions from the environmental settings, the raster calculator, and the surface analysis will be covered in raster analysis 1. As to the raster analysis 2, more different tools in raster analysis will be covered, such as the mosaic, the distance, the row node statistics, and the reclassify tool. Unlike vector layers, the vector layer, each feature is associated with one record that in the attribute table. The raster layer didn't have attribute table for each cell. Without attribute table, there is no place to record x, y coordinates for each cell, and the layer is recorded the coordinates with top and left corner, just one coordinates only, and use the numbers of rows and columns to represent its area. Also, the property will record the resolution of this layer by cell size. For example, here we have 10 by 10 units per cell. The units need to be checked on the projection, so it's probably 10 by 10 meters or 10 by 10 feet per cell. If each pixel and cell is a float type, record here the floating points, the counts won't be able to record. And if that's an unsigned integer, you will be able to see a value table with different counts. The counts here means how many cells are classified with that associate values. For example, for the value 500, we have 35,479 counts. So if that unit will be the feet, the area that being classified as 500 value will be this number, this counts multiplied 10 by 10 square feet. And that is how you get the area of a raster layer. For the environmental setting for raster analysis, first thing here is to set up workspace in specific folder or the M drive. Don't set up that into the geodatabase. Second here is to set up processing extent. The processing extent means how far you will execute your operation. Normally, we will assign the biggest or the main raster layers if the question doesn't specify. If the question has the specified layers, use the layer instead. Third, in the raster analysis setting, you can assign the resolution, which is the cell size, and the end result clipping, which we call to mask here. From the ArcGIS that's help, a mask identify those cells within some specific boundaries will be executed. Similar functionality here is the clip function in vector analysis. So you can set up the mask here, like the boundary polygon. So once you're processing everything in the DEM boundary, the ArcGIS will clip those results within the boundary polygon for you as the end result here. Setup environment doesn't execute anything yet. To execute different types of commands, you will need raster calculator. To start any tool of raster analysis, first you need to click the Customize tab from the menu bar, choose the extension, and click the spatial analysis extension to list the tools within that. After that, in the Arc toolbox, please choose the spatial analysis tools, the map algebra, and click the raster calculator to open up the raster calculator windows. From here, we will need you to download the map package from the goalposts and open it. We will guide you how to execute and operate raster calculator from there. From the raster analysis package, if you have opened everything, I will need to activate the first data frame, the environmental setting. From here, you will see there are two layers. One is the DEM, the other is the boundary polygon of the pack forest. We will need to understand the difference between how to set up the environment. So the first here, we already set up our workspace as here we want to have that into the C drive with the desktop. And we will choose a new folder called the Raster Analysis 1 and edit this to the Raster Analysis 1 to our current workspace, and same with the sketched workspace too. Also, for the processing extent, we want to have it the same as our DEM. You can use the union of inputs. You can use same as display if you are roaming to some specific area, or same as the boundary polygon. Here we choose the same with the DEM. To the raster analysis, we will need you to use the same as DEM. If we choose not to set up any mask, we will end up a DEM layers, just the same DEM layers in our new folder. So let's go ahead and click OK here. And click the Customize to open up the Spatial Analysis tool. From that tool, let's open up the Arc toolbox. And it will take some time to load it up. In the Arc toolbox, we are searching the Spatial Analysis tools, the Map Algebra, the Raster Calculator. So if we set up nothing with the mask and we hit on the DEM, then we should get a DEM only within no mask setting. So if we click OK, and while it's running, you will see there is an extra DEM1 here. It's the same as our DEM1. The processing extent are the same. And if we want to set up the boundary as our mask, so once it processing the whole DEM, we want it clip into the boundary, pack forest boundary. We will need to do the DEM again. And now we are doing the DEM within the boundary. And you will see the second things will happen is the DEM with the boundary here will show up. So every time once you need to get the result within some specific area, go back to set up the mask from the environmental setting. Set up the mask here, click OK, go to the raster calculator using the same layer you use, and it will give you the same layer within some specific boundary. That's how you use the mask, and be sure to set up the right extent before you start any analysis. After finishing the environmental setting, let's switch our monitor back to the slides. The raster calculator is not just used for set up and execute the environmental setting. It has multiple functions. The first function we will use is it's like a field calculator. It can calculate and multiply or plus, minus, or divided the value based on each cell value of the layers. So for example, if we want to multiply each value of this Q 19, 22, 30 layers with 3.2808, we will click these layers, make it multiply 3.2808. In this new raster, we will have each value in a cell that is 3 times larger than the previous. With understanding the concept of doing that, let's switch back to ArcMap and understand how to do that practically. The first is switch and activate raster calculator 1. Click the activate. And if we click that, there is a Q19 1822/30. Let's make it multiply with 3. So you can see everything, the lowest and the highest value will be 3 times difference than what it should be. And we will make this with 3 times difference. And click OK. So in this 3 times difference, you can see the highest and lowest value is 3 times difference compared to the original layers. So if we do the math, we multiply 139 with 3 times, that will be 417. But the reason why we get 450 here is because it's only execute the area and the environmental setting we have for the pack forest. So if we want to do that, we need to clear the settings and make it to our original layer. It's a Q1822. And specify that and delete the mask. So we need to clear the environmental setting every time once you start the new task. So here we want to do that again. Let's make this 3 times 2 and click OK. So now this time it will be totally 3 times difference, and the size will be totally the same as the previous one. So make sure you're aware of the environmental setting every time when you start a new raster analysis task. So let's switch back to the more functionality here. So let's activate the raster calculator 2 data frame and wait here for a while and switch back to the slides. So in the raster analysis, raster calculator 2, it's not only you can multiply or do the mathematics with each cell values, you can also set up a range and make the query work. So for example, for a DEM layer, you can set up, I want it's larger than 1000 but smaller than 2000, which gives you the digital elevation, the elevation between 1000 to 2000. That's how you type in or click the right formula for that. You can multiply and you can do the query for multiple layers and get if you have an ant here, it will have the intersected area between the DEM larger than 1000 and the slope less than 550 here. And for those queries, you will get a 2 value, which is 0 and 1. For the 0 values, which means the value doesn't fit in your query. For the value 1, that means those cells are within your query range. So the value 1, don't even look at the object ID here. You need to look at the value 1. The value 1 is the one that fit in your query, and you will get a count of how many cells to get the area calculation. For the practical operation, let's switch back to the ArcMap. This is the DEM layer we had. We need to go back and set up our processing stand as same as the DEM. The raster analysis with the cell size, and if we want to make it as same as other mask, we can do that. But here I just leave it into the blank. Let's click the raster calculator and let's make it the DEM larger than 1000, and please make sure the blanket is a layer, and less than 2000. So from here, you will get the DEM layers, the values between 1000 to 2000 reclassify as value 1, other reclassify as value 0. Let's click OK. And you will see the 0 and 1 values. Open up the attribute tables from here. The value doesn't seems right to me because you haven't opened up it to the right amount of, you need to drag this a little bit wider and make every value being visible. So here, the one that fit in query, which is the elevation between 1000 to 2000, there will be how many counts. For each counts, we need to go back for the cell size is 10 by 10. 10 by 10 feet. So it's 100 square feet per cell. And I have this amount of cell. So I can get a square feet area for the one that fit in my query, which is the elevation between 1000 to 2000. On the other hand, for the zero values, it means that it's beyond those query. So for the zero value, there's two possibilities here. Either the elevation value is less than 1000 or the elevation value is larger than 2000. So that's how you interpret each value and the counts. Let's do the other things here. If we want the overlap area between the slope and the DM, we can do the DM that's less than 1000 and my slope larger than 50. So that will give you the overlap area between this query and the other query. And if you click OK, you will get those area that fit in the query. That is the green color is the one with 50, the slope is larger than 50 degree, and the DM is less than 1000. So you can see it's just really tiny little area here, and with those counts. So that's how you query a layers from a raster layer by using the raster calculators. The last thing we will cover in the raster analysis 1 is the surface modeling. The surface modeling is taking the digital elevation model, which is the DM, as the base layers and create different type of layer from the DM. So from each surface modeling can be searched from the spatial analysis tools. At the surface, you can create aspects, contour, or the hue shade, slope, or the view shade. For the aspect layer, you basically just put the input and generate an output, name it, assign to the right spaces, and then you have it. For the contour layers, you will need to create the contour interval for that. The contour layers will be a vector line feature classes instead of raster layers. So those two things are here for you to play with.